In this lesson, students will learn about square roots and radicals. They will be able to understand and apply the multiplication property of square roots to simplify radicals containing numbers and or variables in the radicand. So these are some key vocabulary here. The radical symbol indicates a square root. If there is no index written, it is assumed that the index is 2. The index of 2 is the same as the square root. The number underneath the radical symbol, in this case 25, is called the radicand. Now, this is the big idea of this lesson here, is that we can break down square roots using their factors in order to simplify them. If the radicand has a factor in which it's a perfect square, it can be simplified. Now, if you look here, this is the basic idea of the multiplication rule for radicals. If we have the square root of a times b, that is equal to the square root of a times the square root of b. So we can use this particular um, product rule here to simplify, say, the square root of 50. Here's how that is done. First, you take the factors of 50. So I'm splitting this 50 into some factor pairs. 5 times 10 is 50, 25 times 2. However, the one that we would use is the one that has the largest perfect square. In this case, 25 and 2, where 25 is that perfect square number. So we're splitting this 50 into 25 and 2 using this rule here, right? Because now your A is 25 and your B is 2. And therefore, we're able to simplify this here to actually work out to 5 square root of 2, right? Because if you look here, we will see this 50 broken up into 25 times 2, and then it will be square root of 25 times the square root of 2, which works out to 5 root 2. Now, if we can try these two here, right? Simply using the same method, list all the factors, but we notice in this case of 28, um, 4 is your highest perfect square, so we use 4 and 7. 7 is a prime number that cannot be simplified further. So root 28 is going to be equal to root 7 times 4, or 4 times 7. But we know because 4 is a perfect square, that becomes a whole number of 2, because 2 by 2 is 4. So your answer here is 2 root 7. Same thing here, 16 and 2. 16 is your perfect square. You break down the 32 into 16 times 2. Square root of 16 is 4. 2 is a prime number that cannot be broken down. So in this case, your answer is 4 square root of 2. Now, you do the same thing for variables, right? If we have the square root of x squared times y squared, you break this down into the square root of x squared times the square root of y squared. We know the square root of x squared is x, square root of y squared is y. So your answer in this case here is simply xy. Now here, we just have the same thing, but we do have numbers and letters here. So we just break them up. So we have the square root of 18 times the square root of x squared times the square root of y. We know we can break 18 down into 9 and 2, which works out to 3 square root of 2. So we have square root of 2 here, and we know the square root of x squared is x times that x. And we know that square root of y cannot be broken down, so we left that as square root of y. So putting all this together, 3 times x is 3x. And then we'll put this 2 square root of 2 and square root of y together. So it becomes 3x times square root of 2y. And these are two other examples here where we can work this out here. This can be 9 times 3. So that's will become root 3 times square root of 3x. So we're going to do some more practice in this, and I'll see you next time.